Foldable cores are a newly emerging technology. Their core concept lies in clever design, allowing core to be easily folded and stored while still meeting operational requirements, thus saving space. 3D technology has further fueled innovation in this field. Introduction of technologies such as 3D printing and 3D modeling has made design and manufacturing of foldable cores more efficient and precise. Foldable cores not only demonstrate their advantages in three-dimensional space, but also offer remarkable applications in two-dimensional applications. Through their unique structural design, these cores can be easily folded in a planar direction, saving space and revolutionizing product portability. Lateral parting and core pulling mechanisms are indispensable components of mold design, and slides, as key components, play a crucial role. Through ingenious design and manufacturing, slider easily facilitates lateral parting and core pulling in mold, ensuring smooth product demolding and improving production efficiency. In mold design, slider, core component of lateral parting and core pulling mechanism, plays a crucial role. Its sophisticated design and fine manufacturing make it easy to handle lateral parting and core pulling requirements of mold, ensuring smooth product demolding and improving production efficiency. In mold design, slider, another key component of lateral parting and core pulling mechanism, also deserves attention. Its equally sophisticated design and fine manufacturing provide stable support for lateral parting and core pulling, ensuring smooth product demolding and further improving production efficiency. In mold design, slider, another crucial component of lateral parting and core pulling mechanism, also requires meticulous attention. Its design requires meticulous craftsmanship and manufacturing requires unwavering attention to detail. It provides strong support for mold's lateral parting and core pulling, ensuring smooth product demolding and further improving production efficiency. In mold design, slide, another key component of lateral parting and core pulling mechanism, also plays a crucial role. Its design requires careful consideration and meticulous manufacturing, providing a solid foundation for mold's lateral parting and core pulling functions, ensuring smooth product demolding and thus improving production efficiency. As a crucial component of lateral parting and core pulling mechanism, slides design and manufacturing are equally crucial. Carefully designed and meticulously manufactured, slide provides stable support for mold, ensuring smooth lateral parting and core pulling, facilitating smooth product demolding and improving production efficiency. Slide continues to play a crucial role in mold design. It not only supports the entire lateral parting and core pulling mechanism, but also directly impacts product demolding and production efficiency. A carefully designed slide ensures mold stability during lateral parting and core pulling processes, enabling smooth product demolding and improving overall production efficiency.
Single parting surface injection molds are a common type of mold design. Their unique feature is a single parting surface, simplifying mold structure. This type of mold is suitable for producing products with relatively simple shapes, offering ease of design and manufacturing, and relatively low cost. However, for products with complex shapes, single parting surface injection molds may not be able to meet requirements of lateral parting and core pulling, requiring alternative mold designs. Unlike single parting surface injection molds, double parting surface injection molds have two parting surfaces, further increasing mold's complexity. They are often used to produce products with more complex shapes and meet specialized requirements of lateral parting and core pulling. However, due to its more complex structure, design and manufacturing difficulty and cost are also increased accordingly. In mold design, choice between a single or double parting surface requires comprehensive consideration based on specific product shape and production requirements. In design of double parting surface injection molds, selection of mold base and inserts is crucial. C-type mold bases and inserts, with their unique design and superior performance, have earned a prominent place in mold manufacturing. These mold bases and inserts effectively support mold structure, ensuring smooth production. Their convenient installation and removal greatly simplify mold maintenance and repair. Slider demolding is a key feature in double parting surface injection molds. External thread design has been widely used in mold manufacturing due to its uniqueness and practicality. This design not only simplifies mold structure but also effectively improves demolding efficiency, significantly facilitating mold production and maintenance. Push plate ejection plays a vital role in demolding a slider in double parting surface injection molds. Movement of push plate enables precise ejection of slider, ensuring smooth mold release. This technology not only further simplifies mold structure, but also improves the molding stability and efficiency, bringing greater convenience to mold manufacturing. Push rod ejection is an indispensable component in demolding a slider in double parting surface injection molds. Precise movement of push rod effectively pushes reinforcing ribs, ensuring smooth demolding of slider. This technology not only optimizes mold demolding process, but also improves demolding accuracy and efficiency, providing strong support for automated and intelligent mold manufacturing. Push rod ejection also plays a key role in demolding a slider in double parting surface injection molds. Inclined surface design allows push rod to push reinforcing ribs more smoothly, ensuring smooth demolding of slider. This inclined surface design not only optimizes the molding process, but also helps improve the molding stability and repeatability, further promoting the automation and intelligent development of mold manufacturing. Pusher ejection also plays an indispensable role in demolding a slider in double parting surface injection molds. Through proper design, push tube effectively pushes slider for smooth demolding. This technology not only simplifies the molding operation, but also improves the molding efficiency and accuracy, adding new impetus to automation and intelligent development of mold manufacturing. Pusher block ejection also plays a key role in the molding of slider in double parting surface injection molds. Through careful design, push block effectively pushes slider for smoother molding. This technology also optimizes the molding process, improves the molding speed and accuracy, contributes to automation and intelligent development of mold manufacturing. Pusher block ejection plays an increasingly important role in the molding of slider in double parting surface injection molds. Through continuous technological innovation and optimization, pusher block design has become more sophisticated and its pushing force has become stronger, ensuring more efficient and precise ejection of slider. This continuous advancement in technology not only further optimizes the molding process, but also provides strong support for automation and intelligent upgrade of mold manufacturing industry.
Delayed ejection, as an innovative method for demolding slider of double parting surface injection molds, is gaining widespread attention within industry. Through a carefully designed delayed ejection mechanism, timing of slider ejection can be precisely controlled, ensuring smooth and efficient demolding. Application of this technology not only improves automation level of mold manufacturing but also injects new impetus into industry's continuous innovation and development. Round pusher ejection plays a vital role in demolding process of sliders in double parting surface injection molds. This technology enables smoother and more efficient slider ejection, further optimizing the demolding process. The introduction of this technology not only improves the overall efficiency of mold manufacturing but also contributes to continuous advancement of industry. In demolding process of slider in double parting surface injection molds, inclined guide pin side core pulling technology is an indispensable component. It works in conjunction with mold opening stroke to ensure a smooth and efficient slider ejection, thereby optimizing the entire demolding process. Effective application of this technology not only improves mold manufacturing efficiency but also injects new vitality into industry's continuous innovation and development. In design of double parting surface injection molds, single push plate secondary demolding mechanism, with its unique swing block and pull plate design, provides a new solution for mold demolding process. This mechanism not only further optimizes demolding efficiency but also helps improve overall mold performance, contributing to innovation and development of mold manufacturing industry. In design of double parting surface injection molds, another noteworthy single push plate secondary demolding mechanism is spring type. This mechanism cleverly utilizes spring force to achieve rapid mold demolding while ensuring stable and reliable demolding. Its ingenious design not only optimizes demolding process but also helps improve mold production efficiency, bringing new breakthroughs to mold manufacturing industry. In addition to spring-type single push plate secondary ejection mechanism in double parting surface injection mold design, another important mechanism type is inclined guide pin slider type. This mechanism, through clever coordination of inclined guide pins and sliders, also enables rapid mold demolding, exhibits excellent stability and reliability during demolding process. This innovative design not only simplifies demolding process but also further improves mold production efficiency, bringing significant advancements to mold manufacturing industry. To ensure a smooth demolding process, inclined guide pin slider type single push plate secondary ejection mechanisms often incorporate a spring pre-reset mechanism. This mechanism utilizes spring's elastic potential energy to quickly return slider to its original position after demolding is complete, preparing for next demolding attempt. This ingenious design not only improves demolding efficiency but also ensures mold continuity and stability, further optimizing mold performance. In a secondary ejection mechanism with an inclined guide pin and slider, a single push plate ejection mechanism of fixed mold plays a crucial role. This mechanism allows mold to quickly return to its original position after demolding, ensuring a smooth next demolding cycle. This design not only improves demolding efficiency but also effectively optimizes the overall performance of mold.
In a secondary ejection mechanism with an inclined guide pin and slider, a single push plate design of parting surface is crucial. Parting surface must be vertical to ensure smooth and efficient mold movement during demolding. This design not only impacts mold demolding effectiveness, but also has a profound impact on the overall performance and service life of mold. In a secondary ejection mechanism with an inclined guide pin and slider, parting surface must not only be vertical, but also often adopts a stepped parting surface design. This design further optimizes the molding process and improves mold efficiency. A cleverly designed stepped parting surface ensures smoother and more stable demolding, thereby extending mold service life. In mold design, parting surfaces are generally categorized into two types, flat and curved. Flat parting surfaces are simple to design and suitable for parts with regular shapes. Curved parting surfaces, on the other hand, better accommodate the molding requirements of complex parts. Through careful design, they ensure a smooth and stable demolding process. In mold design, a horizontal parting surface is a common type of parting surface. Its characteristic is that parting surface is parallel to the bottom surface of part. This design approach is particularly suitable for large parts or when a large demolding clearance is required. A well-designed horizontal parting surface can effectively ensure a smooth demolding process, while also improving part quality and production efficiency. In mold design, reset rod's reset action is crucial for ensuring proper mold operation. Through clever design of riser rod, mold components can accurately and smoothly return to their original positions during the molding, ensuring smooth operation of next injection molding cycle. In mold design, it is sometimes necessary to adjust parting line position. By properly adjusting layout of parting line, you can optimize product's appearance and functionality to meet specific production requirements. Clever design in this area is crucial for improving mold performance and product quality. Mold pin positioning is a critical step in mold design. Precisely adjusting position of parting pin ensures mold's parting line is optimally positioned, optimizing overall product design and production efficiency. This step is essential for improving mold performance and product quality. Movable inserts are widely and critically used in mold design. By cleverly utilizing movable inserts, you can further optimize positioning of parting pin, achieving a more optimal mold parting line layout, thereby improving overall product design and production efficiency. Design and implementation of movable inserts are crucial for ensuring continuous improvement in mold performance and product quality. Gate design is crucial in mold design, directly influencing formation of weld marks. Excessive or insufficient gates, as well as improper gate positioning, can lead to weld marks, which in turn affect product appearance, quality, and performance. Therefore, during mold design, it's important to fully consider impact of gate number and location on weld marks to optimize product design and improve production efficiency. In mold design, adding a cold slug trough can be a viable approach to further reduce weld mark issues. This cold slug trough effectively reduces thermal stress during weld process, thereby improving weld strength and ensuring consistent and enhanced product quality. This design strategy has been widely adopted in mold manufacturing and has achieved significant results.
Incorporating air valve air induction into mold design can further optimize weld quality. This design precisely controls amount of air bleed, reducing bubbles and defects during weld process, thereby improving weld quality and product performance. Application of air valve air induction in mold manufacturing provides a new solution for optimizing weld mark issues. By incorporating air valve air induction into mold design, amount of air bleed can be precisely controlled. This technology not only helps reduce bubbles and defects during welding process, but also significantly improves the overall weld quality and final product performance. Its application provides a more efficient solution to weld mark issues in mold manufacturing. Application of an air valve ejection mechanism is crucial in mold design. This mechanism enables precise control and adjustment of air entrainment volume, thereby optimizing welding process and reducing occurrence of bubbles and defects. This design not only improves the overall welding quality but also effectively resolves weld mark issues during mold manufacturing, significantly contributing to improved product performance. Selection of a push plate release structure is crucial in mold design. This structure effectively facilitates mold release and ensures smooth product ejection. A well-designed push plate can further optimize welding process and improve overall product quality. It can also resolve weld mark issues during mold manufacturing, providing strong support for improved product performance. Equally important in mold design is selection of a push plate release structure. This structure further facilitates mold release and ensures smooth product ejection. A carefully designed push plate can further optimize welding process, thereby improving overall product quality. It can also effectively resolve weld mark issues during mold manufacturing, laying a solid foundation for further improved product performance. Among many mold design structures, push plate release structure 3, with its unique design and functionality, holds an indispensable position. This structure not only further simplifies the molding process but also significantly improves product ejection efficiency. Through a well-designed push plate design, welding process can be precisely controlled, thereby ensuring consistently improved product quality. It can also effectively reduce weld mark issues during mold manufacturing, contributing to overall improvements in product performance. In push plate release structure 3, coordination between push plate and core is crucial. Through a carefully designed push plate and core coordination, welding process can be precisely controlled, ensuring consistently improved product quality and performance. This coordination not only simplifies the molding process but also significantly improves product ejection efficiency, bringing significant benefits to mold manufacturing optimization and product quality improvement. Based on push plate release structure 3, further exploring push rod ejection mechanism is also a key step in optimizing mold manufacturing. By rationally designing push rod ejection mechanism, we can further improve demolding efficiency and product ejection quality, opening up new possibilities for improving mold manufacturing processes and product quality. Based on our in-depth research into push plate ejection structure type 3 and push rod ejection mechanism type 1, we further explored the diverse possibilities of push rod ejection mechanisms. This exploration not only impacts mold manufacturing efficiency but also has significant implications for improving product ejection quality and optimizing the entire manufacturing process. Through continuous innovation and improvement, we can bring more technological breakthroughs to mold manufacturing industry, thereby driving continuous improvement in product quality. Thank you.